Okay, I started the recording. So hello everybody, welcome to our second week. I wanted to start first by just checking, if there's anything that came up from last week, like any questions you guys had, or anything that you wanted to go over again before we start, going into new content. So if you've got any questions, just ask, or you can put them in the chat as well, and I'll open that. Okay, that sounds good then. I guess I explained everything super well. So, okay, so last week we essentially covered, the basics of what a blockchain actually is, the technology. It's a kind of shared ledger or a database that can be shared across the whole world, like between multiple people. And because of the kind of novel consensus algorithm, we are able to trust each other that we've followed the rules of the database and we're not tampering with the database without having kind of a central point of failure. So that's in this decentralization kind of diagram that we were talking a lot about before. A centralized database, like a bank database, for example, it's a single kind of point of failure of the whole system. All of these different people are connecting into a single bank, which means you're trusting the bank to do the right thing. If you want to move to another bank, you can't really take your data with you. There's a lack of privacy. You don't know what the bank is looking at. It's a single point of attack if you have a malicious kind of hacker or a government wants to shut down certain people from transacting with each other. You've got kind of that point of failure. So there's all these disadvantages with a centralized system. Then what we're kind of talking about is that blockchain then moves along this diagram into the distributed part of the system. So we have a kind of network of people or nodes, which are these little dots, and they're all talking to each other to share data. Then that data has been propagated around this network. So if, say, this node here wants to make a transfer of cryptocurrency, they want to send a Bitcoin to someone, then that transaction, which moves that Bitcoin, gets sent to all the other nodes in the network, and together they all agree on what is true. And that's kind of the big advantage of blockchain, is it's that shared decentralized database. So last week we talked about Bitcoin mostly because it's the kind of most widely known, quite a simple blockchain. It deals really only with transferring cryptocurrency back and forth. But today, and for most of this course, what I want to focus on is another blockchain called Ethereum. Whereas Bitcoin is essentially just a digital currency, Ethereum takes that idea and takes the advantages of a blockchain, and then it extends it to a much wider range of use cases. And this is why I think it's so great for us, as developers. We all want to be creating decentralized applications that can run on this distributed network. And to do that, we need a bit more power than just being able to send money back and forth. So I'll talk about what Ethereum is today. We'll also do a bunch of kind of hands-on stuff. So hopefully everybody has either a browser like Chrome or Firefox installed. That's all you really need. But if you don't, maybe in these introductory slides, just install that because we'll be doing, we'll connect to the Ethereum network and send some cryptocurrency around and things like that. So let's talk about, come back to that. Let's talk about Ethereum. So Ethereum is a blockchain, just like Bitcoin. It's a shared database around the world. And also just like Bitcoin, it does have a cryptocurrency. So whereas the Bitcoin cryptocurrency is called Bitcoin, in Ethereum, it's called Ether. So you've probably also seen, the price of Ethereum or the price of Ether has also become quite high. So whereas Bitcoin is like $40,000, an Ether on Ethereum is 3,500. So you can see this is also a super widely used coin and a very popular network. It's the second largest blockchain after Bitcoin. And it's the most widely used blockchain in terms of number of users. So Bitcoin is more widely used in terms of the amount of money that's on it, or the amount of kind of transactions. Ethereum is the most widely used by applications and smart contracts and things like that, which we'll talk about. So as well as its native currency, that's kind of just one base component. The real advantage of Ethereum is that it can run computer programs. So if we think about, I know we've got at least one Java developer. When you write your Java program, it's executed both on your computer, obviously, but it's also executed using something called a virtual machine. And a virtual machine is, in essence, just a simulation of a computer, right? So it understands instructions like a computer does. It knows to add two numbers together or multiply two numbers, store a number in memory, and so on, right? So your CPU on your computer can do that, but then between different computers, those instructions might not be the same. You know, if I have a Apple computer running an M1 processor, the things that my actual CPU chip can do are different than if I had, say, an Intel computer. What a virtual machine does is that it makes all of those instructions kind of common to whatever hardware it's running on. So the Java virtual machine can add two numbers together on any processor. It doesn't need to know kind of the underlying hardware. That's probably one of the reasons why, you know, you can write a Java application and run it on an Android phone. Sorry.
Hello, Saidul bhaiya.
Hello.
Hi.
Hello, আপনি হচ্ছে ভাইয়া মিউট করেন।
What's going on, sir?
Sorry for the interruption.
Oh, all good. Okay, cool. If you have any questions, just jump in and interrupt me if I'm not stopping talking. Yeah, so the Java virtual machine is, you know, what the reason why we can have programs that run on an Android phone and on a computer and on a server, right? It abstracts over the underlying hardware. Is someone asking a question? Don't know if I've lost connection.
Sorry, Saidul, we have some problem with the internet here. We try to fix it.
Is it okay now?
We are trying.
Okay, I'll just pause for a sec then while you guys do it. How's that? Can you guys hear me now? Great.
Yeah, we're extremely sorry, Cadel. We're having some difficulties from our end.
Yeah, that happens. Am I good to keep going?
Yeah, we can continue.
Okay, cool. I'm not sure when various people dropped out. So in essence, what I'm talking about is what a virtual machine is. And it's a simulated computer that runs on, you know, your actual computer hardware, and it abstracts away the hardware.
Right.
So we've got a virtual machine. Think of it like the Java virtual machine. The next kind of level of abstraction, we've gone from hardware into software. Now, what if we can take this computer and instead of running it on, or take this virtual machine, instead of running it on one computer, we run it on every computer in the world. And that's the promise of Ethereum. So it takes this virtual machine and it makes it distributed. So instead of, you know, each of us having a computer that kind of sends messages to each other and stores data on our own computer, we're all sharing this gigantic global virtual machine. We're all running our programs on it, storing data on it, and so on. And we can all interact with those programs together. Just by thinking about, you know, a distributed virtual machine, you can imagine that it can do so much. You know, you could, for example, create a bank. You could create a marketplace where people can buy and sell goods. And this program is running on everyone's computer at once. What's kind of really awesome about blockchain is that using the blockchain, you can build the virtual machine almost as easily as you can build a cryptocurrency. So if you remember, we were talking about state transition functions, and that's the kind of function that takes a database and a new block of transactions, so a new group of transactions, and then applies those transactions to the database to give us a new database state, right? So in Bitcoin, it's like Cadel transferred 500 Bitcoin. In a distributed virtual machine like Ethereum, that's only one of the instructions available in the state transition function. You might now have a state transition function which can take in an add instruction or a store this number in this memory address instruction, and so on. And so your state transition function becomes in some ways a lot more complicated, but it's also a lot more kind of flexible in general. And that's why Ethereum is so kind of exciting and so good for actually building applications rather than just transferring between people. So let's talk about the network itself. So the Ethereum network was created in, I think, 2016 maybe. And now it had 8,000 when I made these slides, but that might have changed now, nodes in the network. And each of the nodes is kind of running their own client of the Ethereum blockchain, and any program or any cryptocurrency transfer that we make on the Ethereum blockchain goes to all of these nodes to validate. So as of today, there are 5,611 nodes around the world connected to the Ethereum network. And one of the cool things about cryptocurrencies is this isn't really just in one country, right? If we look at this kind of map of the world, and you can see that in the US at the moment, there are 2,000 nodes connected to the network. In Australia, we've got 66 nodes. Unfortunately, I looked at Bangladesh and there are currently 0 nodes there. So maybe that's something that you can all help fix. But, you know, it's pretty general. Like we can see that most of these countries have, or most of the kind of larger and more European, US kind of style countries have some nodes at least. What that means is then if Russia or if China, if the government decides to crack down on Ethereum, then it just keeps on running. You know, if 36 nodes from China are blocked from accessing the Ethereum network, then all of these other nodes can still continue and the network is more resilient to failure. Whereas you imagine a bank in China, if the government orders them to shut down, then the whole system is gone. So that's one of the cool things. So this is just like we had a Bitcoin white paper. So the kind of description of the whole system. It's an announcement of the blockchain. It's a description of how it works, what the state transition function is, and so on. We also have an Ethereum white paper. So this was published first in 2013. Then the network itself was launched in 2015. There you go. The person who wrote this, his name is Vitalik Buterin. And unlike Bitcoin, he is not anonymous. So this is an actual guy. He's Russian. He's extremely smart. You can watch his talks on YouTube. You can read his blog. He knows an incredible amount about maths and cryptography and economics. And at the time, you know, when Bitcoin was kind of just starting to gather steam, he was really excited about the idea of blockchain. And he thought that he could then apply it to create this world computer that is Ethereum. And so he kind of released this Ethereum white paper. Now, if you're interested, you can read this. It does get a lot more complicated than the Bitcoin white paper. So it talks first about Bitcoin and how kind of blockchains work in general. Then it moves on to Ethereum. It talks about the kind of design philosophy of Ethereum. And it talks also about potential applications for Ethereum, which is a lot of what we'll talk about today. So this is all really interesting as well. There is also, on top of the white paper, we have something called a yellow paper. I don't know why they named this, but the yellow paper is like the white paper, but a lot more technical and formal. So if you're a developer, you want to know how Ethereum works, read the white paper. If you want to build a node that connects to Ethereum, read the yellow paper. And you can see kind of the exact equations that they use to build out an Ethereum client. So it's very, very complicated. I haven't read this one, to be honest, because I don't understand a lot of the maths, but it's there if you're interested. So one of the really cool things about Ethereum, as opposed to Bitcoin, is that every node is not just running one kind of software client. In Bitcoin, when you run a Bitcoin node, you're running the Bitcoin software. There's a single kind of download that you download into your computer, you run the program, everyone's running that same program, which is good because it means that Bitcoin can be upgraded quite easily. But it also means that if there's a bug in that Bitcoin client then that affects the network, then the whole network is going to go down at once. What Ethereum kind of did differently is that they didn't create a client straight up. They first created an open standard that describes how the blockchain works, how the clients, how the nodes should work. And then they got multiple development teams to all build their own clients that connect to the Ethereum network. So on the network, it's not just one program running, it's 5 or 6 different programs made by different development teams that all connect to the network and run the same blockchain kind of programs. So if we look at the node tracker again, and we go down to this client section here, these are all of the different node kind of types that are running currently. The kind of major ones, we've got GETH. This is made by the Ethereum Foundation, which are kind of, the non-profit organization that guides Ethereum and guides the Ethereum community. And so about 40% of nodes around the world are using the software developed by the Ethereum Foundation. The kind of second major one is called Open Ethereum. And then maybe the third, that's old, is another one that I use personally, and this is called Besu or Hyperledger Besu. And these are all written in different programming languages, like GETH is written in Go, Open Ethereum is Rust, and Besu is Java. But because we've got that open standard and because we've got this Ethereum yellow paper, which describes everything in extremely formal language, all of these clients can communicate together and they can agree on what is true about the Ethereum network. They can agree on how programs run and so on. So that's really cool. Where did the slides go? We will also talk a lot later, maybe not today, but in the course, about Ethereum 2.0. And this is a huge effort by the community to kind of improve Ethereum and fix a lot of the problems in it, which we'll also talk about. So as well as just these nodes which exist for Ethereum 1.0, there's going to be a lot more clients. And so they're kind of coming soon. We'll talk about that. Any questions so far?
Oh, clear.
Cool. Right, so we went through this last time, so there's no need to repeat, but Ethereum blocks work almost exactly the same as Bitcoin blocks. You've got your transactions, put in the block, then they're linked to the previous block with a hash. Now, the contents of the transactions, this is where it starts to become really interesting. just like Bitcoin, and when we're looking through the Bitcoin kind of block explorer, you do have transfers of cryptocurrency, Ether. So I'll look now in Etherscan. So Etherscan is just like the Bitcoin block explorer, but it's for the Ethereum network. I think it's a lot better than the Bitcoin block explorer. And I'll kind of show you all the features throughout this course. But right now I'm looking at a single transaction that happened in 2019. We can see all sorts of information just like in the Bitcoin. So we can see that the transaction hash, or the ID of the hash is here. We can see that it was successfully mined and it ran on the network. We can see the block that it's in. And you'll notice that the block number in Ethereum is a lot higher than Bitcoin. And we'll kind of explain why that is in a second. You can see the address, or the person who sent the money, the person it was sent to, and then the amount of Ether that was transferred. So in this case, it was something like 31 US cents. And you can also see what the price of Ethereum was at that time, which helps with this conversion here. There's more details too, which we'll talk about soon. Now, if I click through to the block, there's a few things to notice here. The first is that the number of transactions is a lot lower than Bitcoin. Bitcoin, we were seeing a few thousand transactions per block, whereas Ethereum here we have 145. We can also see that if I go to, let's go to the whole list of blocks as well, that Ethereum blocks are created a lot faster. So rather than taking a couple of minutes to create a new block, they're happening every 12 seconds or so. And what that means in practice is that you can make your transactions a lot faster. I know we're talking about Bitcoin, that if you wanted to receive payment for a physical item that you were going to hand over to someone, you would have to wait up to an hour to make sure that the money had transferred. With Ethereum, it's something like a minute if you wait for 6 blocks to pass. So it's a lot faster, which is one of the advantages. The trade-off then is you can have kind of less information per block, which is interesting. Let's go back. So that's the most basic type of transaction. Someone sending money to someone else, just like Bitcoin. But we have kind of the second type of transaction, the much cooler type of transaction, is a smart contract transaction. So let's jump through and have a look at this one. Now we can see there's a few things different in this transaction and a few things the same. So there's still a transaction hash, the ID, there's still a block that it was in. We still have an address that's creating this transaction. However, instead of having money sent, we can see here that 0 Ether was sent. We have this new interacted with field. And here, instead of sending money, someone is interacting with the smart contract. And a smart contract is just a program that's running on a distributed virtual machine. So I can actually click through and look at this program. So I'm now looking at the contract with this ID, this address, and we'll go into more detail about the smart contracts. But I can actually see the code of this program. So I clicked on the contract, and in this little box, which I'll make bigger, we can see that this is a full computer program. It's readable just like a normal programming language, but it's running on that distributed virtual machine. And a lot of this course will be how we actually write one of these smart contracts. But it's kind of cool just to see that this is right now out there on the Ethereum blockchain. It's at a certain address and people are interacting with it. If I look at this transactions tab too, I can see that all of these people have been interacting with the contract, and I can see what kind of function or entry point they're calling in the contract as well. So this just looking at it looks like it might be a smart contract, like a cryptocurrency token. And we'll talk a lot more about them too. But it's all kind of publicly available. You can go into Etherscan and start looking at these contracts, which is awesome. Okay. Now let's get into a little bit of the technical details. So by adding smart contracts to the network, there does introduce quite a large problem. That problem is that in say Bitcoin, where you're transferring cryptocurrency to each other, the amount of work to do one transaction is always the same. You know, if I'm transferring $50 to a leaf, that's exactly the same amount of work for a computer as if I was transferring 10 billion, right? So there's no way to kind of attack the network by spending more money, if that makes sense. However, we all know that with computer programs, some programs take longer than others to run. If you've heard of the term Turing complete, it really means, you know, like it's a certain kind of power that a program has. And a Turing complete program can, in essence, repeat over and over again forever. So it can have a loop, just like a for loop or a while loop, that runs forever. And because Ethereum smart contracts are Turing complete, the problem comes that if someone were to upload a program that had a loop in it that ran forever, it would lock up the whole network, right? Because everyone's computers would start running this program and it would loop forever and no one else's programs or transactions will be able to run. So that's kind of the problem introduced by running smart contracts, is that you start to run into programs that take longer than others and that might run forever. So to fix that, what Ethereum did was it took the concept of transaction fees from Bitcoin. So you're paying the network a little bit of Bitcoin to transfer your coins, and it made them proportional to the size of the transaction. So the bigger the program or the more complicated the program you run, the more it costs you to run it. This means that, you know, people are incentivized to both write smaller contracts, make their programs more efficient so that they cost less to run, and so on. And it also means that you can set a kind of total transaction limit. And if a program is more complicated than that, or if it runs until it hits that limit, it will be killed and it will fail. And that stops someone creating that infinite loop. You know, if it might run 1,000 times, then it will hit the kind of transaction fee limit and then it will be killed. So it's impossible then to clog up the network completely. If you start, you know, getting into Ethereum, you'll see this term gas a lot. And gas is just like, you know, petrol, right? It's the fuel that a program needs to run. And it's a measure of how complex the program is. So when you take that smart contract that we saw that's written in the human readable language, it's compiled down to machine instructions, just like a computer. So where you've got a for loop, that might become add, jump, check, so on, like the really kind of bite-sized instructions. And some of those instructions are more complicated than others. So for example, storing a number in memory where everybody can access it is a lot more expensive than just adding two numbers. So depending on how kind of complex and how hard each part of the program is, that changes the amount of gas that it costs. Then you kind of add up the gas of the whole program and you might get a number like 40,000. And you know, this program takes 40,000 gas to run. Then you multiply that amount of gas with the gas price, which might be, say, $0.0001 per unit of gas, and then you get the final transaction fee. So you can see that the more complicated your program, the higher the transaction fee. If we go back to, this contract we were looking at before, we can kind of see that in action. So if I go to, this is my source code, right? And this is written in a language called Solidity that's inspired by, you know, a few languages like Java and C and so on. And so this is the human readable language that smart contract developers and application developers actually write. Then the compiler kind of compiles it down to these these machine readable instructions. And if I click this switch to opcodes view button, you can see that, you can see then these kind of like tiny bite-sized instructions that I was talking about. So instead of a loop here, we've got a jump I or a dupe I, you know, and these are instructions that the computer understands rather than the programmer. Then each of these instructions here has an amount of gas associated with it. And if you wanted to find the exact amount of gas for each of these instructions, we would go to the yellow paper where they have a big list. And I might show that in a second. And then this adds up to essentially the size of the contract and how much it costs to use it. So if I look then at the transactions that have called this contract, that have interacted with it, and I just pick, say, this one here, which is using the transfer function of the contract. So I'm now looking at the actual transaction that called that function in the contract. So this is calling a function or a method in the contract called transfer. And we can see, if I go to more, that calling this program here costs 53,000 gas. Then it's multiplied by the gas price, which in this case was a tiny amount of ether per gas. So that multiplied by the gas used by the transaction ended up in this transaction fee, which was $2.31. And that's kind of how they're priced. If we look at the yellow paper, let's find the gas section. I think it's an appendix. So here, the authors have kind of listed out all of these different instructions. So that jump I that we're looking at is where it might be not in this table, but say, let's look for an easy one. Okay, SHA-3. So remember we were talking last week about hash functions, right? The hash function that takes in, any input and results in kind of a smaller input that then can't go back the other way. Well, the Ethereum virtual machine has a function or a instruction that can do that hash. And to do that, it costs you 30 gas. So just, making one hash might cost 0.001 cents. Right? But something that's a lot more expensive, like destroying a contract using the self-destruct instruction, might cost heaps more gas. So 24,000 compared to 30. What that means is that the contract developer has to be really careful about what instructions they're including in their contract to make sure that it's not too expensive to use. Okay. So that's the transaction fees. If you are a user of smart contracts, then you'd use this thing called ETH gas station, and this will tell you how much to include in your transaction fee. And when we start doing the interactive stuff later on, we'll use this to work out how much our transactions are worth. Now let's look at this cool interface. So this is a program called ETHstats. And it looks quite daunting initially, but this is another view of the Ethereum network as a whole. So I'll just make this a bit bigger so we can see it. But what we can see here in this big list, these are all the nodes that are connected to the Ethereum network right now. So it's voluntary to opt into this screen, and you can set a name. So you can see that, this node here is owned by the website 2miners.com. And you can see kind of more interesting information, that you can see what software they were running. We're talking about there's different node types in Ethereum. All of these people here are running DETH. And you can see also, their address and so on. You can see their uptime, so how often they were connected to the Ethereum network. All of these nodes here have been connected 100% of the time. But being a distributed network, if one of these drops off and then comes back later, it will just reconnect and catch up. That's kind of part of the fault tolerance of blockchain. And you can see how long it takes to connect to one of these nodes. So some nodes are slower than others, or they might have worse internet than others. Like there's that node there that looks like it might be in the middle of Australia where the internet's pretty crap and so on. And then you can also see here that we're currently up to 12 million blocks, so about double Bitcoin. The average block time is 13 seconds. The total hash rate of the network, so how much computing power the whole network has, is listed here as well. And we get, kind of nice graphs of block time and so on. And we'll come back to this screen too throughout. There's some other useful stuff. Now, hopefully you remember we talked a lot last week about proof of work as a consensus mechanism. And this is what secures Bitcoin. It's also what secures Ethereum. So the network is secured by computing power, raw computing power. And it works just like Bitcoin. Every block has to start with a certain number of zeros in its block hash. And miners race to find the number that results in a hash that's kind of less than that difficulty. So it works exactly the same as Bitcoin. That's what you could see on that ETH stats page, right? The network hash power is how many total hashes the whole network can calculate every second in the pursuit of finding a new block. So there's less hash power on Ethereum than Bitcoin, but there's still an awful amount. And returning again to that graph that I showed last week, you can see that to generate $1 worth of Ethereum, it's costing 9 million joules. Joules is a unit of electricity, which is more than, say, gold mining worldwide. Right? So it uses an insane amount of electricity. The difference kind of between Bitcoin and Ethereum is that the Ethereum community has recognized how much of a problem this is, and they are moving away from proof of work towards proof of stake, which I talked briefly about last time, where instead of securing the network with mining power or hash power, it's instead secured by how much Ethereum currency you own. And that's what the big Ethereum 2.0 effort is all about. All the new clients that people are building are to support that proof of stake and some other improvements. And hopefully by the end of this year, we'll see that change made and we'll see Ethereum become a lot more environmentally sustainable. Okay, let's talk next about accounts. So we kind of glossed over this in our Bitcoin explanation, but when we want to use a blockchain network, we need some way of identifying ourselves. We need some name that's mapped to how much Ethereum we own or how much Bitcoin we own, or saying that we are using the program as opposed to someone else. And we could just use, like if we were in Australia, we could use our Australian business number, or I don't know if there's like a social security number in Bangladesh. However, in a whole kind of world scenario, there's no unique ID that identifies every person. So we needed a kind of new identification system in the form of accounts. The way an account works is that you have a private part and a public part. The public part is like your name, right? It's your address. It's how people identify you. And if we looked at that transaction that we were looking at before, where we see the from field, so this is who created this transaction, who interacted with the smart contract. This address here is someone's public account name. So it's a hash, just like a lot of things in cryptocurrency. So just saying that number, I don't know which actual person in the world this is. But if someone told me their name, I could then look them up on the blockchain and see what they've been doing. But if we just kind of could send from any name, then that means that the promise of blockchain is kind of destroyed, right? If I could just say, oh, I want to transfer from this account, I'll send all the money to my account, right? If I could do that, then that would defeat the purpose of the blockchain. So an account also has to have a private part. And the private part is a key which lets you use this address. So if I wanted to then replicate this transaction, I wanted to call this contract from this address, I would need to know the private key that corresponds to this account. And the private key is just like a password. So you would want to keep it secure, keep it safe, not share it with anyone, because if you do share it with everyone, you've essentially lost your money because someone can then transfer it to themselves. Let's do a little demonstration of what this looks like. So what I've got here, you can also try this out if you like. It's I'll send around the link later too. But we have here an account generator, which works for a lot of different blockchains. So it works for Bitcoin as well as Ethereum. But what I'll start off by doing is generating a secret key for myself. I can just click generate. And we can see here, this mnemonic here is my secret key. So if this was my actual account and you all saw me show this online, you could now use this key here to steal all my money. So make sure you never actually show this to anyone. But for the sake of demonstration, let's go through it. I'll just change my coin to Ethereum so that this makes sense. So we've got our kind of private key or our secret key. And now if we scroll down to the bottom, we can see this derived addresses part. And so just using that private key, that kind of master list of 15 words, we can then start to create multiple accounts. Each account has something called a nonce. So a nonce is just like the number of your account. I might have 5 accounts, for example. So I've got accounts from 0, 1, 2, 3, and 4. And then, so just based on my private key, I generate all of these different addresses. And these addresses are what I use to interact with Ethereum. What that means, like in practice, is with one private key, I can be 100 different people on the Ethereum network. And there's no way to tell that that's happening, but I can control it all with one key. That's really cool. So if I were to issue a transaction from this address that starts with Nonce, like I wanted to send money from my Nonce address, I would create the transaction and then I would use my private key to sign it. And signing it means kind of taking the private key, taking the transaction details, doing some maths, doing some cryptography, and resulting in what's called a signed transaction. Then anyone can verify that this came from me by checking my address, checking my public key, and making sure that the transaction did come from me. This is what stops then Alif or Akia or someone else signing a transaction using my address. If they don't know the private key, then the verification will fail and the transaction will be rejected by the network. What this also means is that if you say have someone's address and you wanted to take control of it, you theoretically could by guessing their private key and checking until it matches. However, because there's something like, what's this? This is hexadecimal, so this is 16 to the power of 256 or something like that. It would probably take you like longer than the entire universe's existence to work out that private key. So that's why it's so secure. Now it's quite clever how the developers have managed to turn the private keys into this English sentence. What's also really cool is that the private key can be represented in different ways. So if you are a user in China and you wanted to see your private key in Chinese, these are also perfectly valid Chinese words. It's the exact same private key, the same account as the English account, but it uses different words that are more useful for your language. Same in French, right? These are all words like motor, for example. Just like in English, we're using gadget. So it's really cool, I think, anyway. Now let's talk about one more kind of big component of the Ethereum network. We've talked a little bit about smart contracts, doing things, transferring money, adding numbers together, calculating interest rates, things like that. But in order for that to be actually useful, we need to be able to store data somewhere. And smart contracts have a mechanism which allows them to store any data they want in the global computer. So it's not just kind of a global CPU processor, it's also a global hard drive. And the programs can read and write to their hard drive to store information persistently or to store it, forever. What that means is that Ethereum blockchain takes quite a lot of storage. So it's at about 231 gigabytes. You can kind of compress it and you can remove some of the outdated data and get it down to 50 gigabytes, but it's still quite large. And you can see that over time, the amount stored in Ethereum is increasing quite rapidly. So a lot of people are worried that this blockchain is going to become too huge. It might take 3 hard drives to be able to store all the data, in which case, you have a problem with people being able to access the network and being able to afford to use the network and so on. So there's been a couple of approaches to fixing this. Some of them are going to be included in Ethereum 2.0, so some technical changes to decrease the storage. And then the other kind of big incentive to reduce the storage is that any operation or any instruction in a smart contract that adds to the storage of the blockchain, so that stores data, it costs quite a lot of gas compared to just computing information. So if we look back at the yellow paper, we can see that something like S set here, which is storage set, adding memory or adding data to the network, costs 20,000 gas, as opposed to say 2 gas to add 2 numbers together. So it becomes quite expensive in real world money to actually store a bunch of data on the network. And that's one of the key issues with decentralized applications, right? If you're trying to replicate a game or something like that on Ethereum, a computer game, and you have heaps and heaps of data, you can't store that all in the network, and you need a decentralized hybrid solution. We'll talk a lot about that when we get to kind of the development part of this course, how you can manage the storage usage of your contract and so on. So it's a really important thing to think about when you're building out smart contracts. Okay. So let's talk a little bit about the disadvantages of smart contracts. So the state transition function of a blockchain network is there to make sure that everyone plays by the rules. So you can't spend someone else's money, or you can't spend your own money twice. You can't, in the smart contract case, give the wrong answer from adding 2 numbers together. For example, 2 + 2 has to equal 4, or else the network will reject your transaction. But what that doesn't help is if the smart contract itself has a bug in it. We've all written bugs in our programs, which is fine, we just fix them. But the issue with smart contracts is that once you've loaded it onto the network, it's there forever. So if you've got a bug in there that someone can find, it's very, very difficult to fix it. And if it leads to a way to extract money that you wouldn't be able to access normally, it can lead to huge losses of money. So these are 2 notable examples in Ethereum history. The first is probably the most well-known. It's the DAO hack. This was a big smart contract that the whole Ethereum community kind of contributed to. And the idea of this contract was to make a program that would allow everyone in the world to vote on projects that the world should fund, right? So say a developer wanted to build out a new programming language, or they wanted to build a program that would solve world hunger and so on. They could apply to this smart contract, and then people around the world would vote and they would receive funding for their project. They might say, I'll need $1 million to make my project happen, and so on. So people thought this was a great idea. The whole community put in an enormous amount of Ethereum into this contract. In fact, $678 million was in the contract. And then an unknown hacker found there was a bug in the contract. They found a way to take all of this Ethereum out and transfer it to their own account, even though the community hadn't voted on that. And they essentially stole almost $1 billion. So that's kind of shows the enormity of the problem with these buggy smart contracts. This was in, I think, 2016 or 2017. It was in kind of the early stages of Ethereum. More recently, there was a smart contract that served as a wallet for a group of people. So it stored Ethereum cryptocurrency. And again, hackers found a bug and stole $30 million. And you can, if you follow the news around Ethereum and around blockchains in general, you'll see that hacks like this happen almost every week. And it's really, really hard to write your smart contract in a way that will prevent it from happening. And that's one of the reasons why blockchain development is so difficult, because even experienced developers, even people who've built many smart contracts before, make these mistakes and lose all their money. Like this DAO hack, the people who wrote this contract were the people who wrote Ethereum. So they're not bad developers, but it's so easy just to make a tiny mistake and lose all this money. So one of the things we'll talk about in this course is how you can avoid making that mistake. There's a lot of ways to test your contracts and so on that will prevent something like this from happening. So In the past, there's been a couple of ways that the community has responded to buggy smart contracts or problems with the network. The first is something called a hard fork. And if we remember back to last week, we talked a bit about the network forking. So if we imagine here, we've got our list of blocks, and you can see that here, you've got block 97, then block 98, then block 99. If two people were to find a proof of work solution for the next block at the same time, you would have a chain fork. So you can see here, 2 blocks have been selected here. But the network usually then picks one of these forks and continues with it. And this fork here is lost. So these blocks are discarded. But what you can do if you have the whole community behind you is you can essentially do the 51% attack that we were talking about last week. And you can forcibly make the whole network switch to this fork. And after this DAO attack, so where they lost the $678 million, the whole community got together and they did this hard fork. So they all forcibly attacked the network that they themselves were on to recover the money. So that's kind of one way if you've got the whole community behind you. That's only ever happened once after this attack. People have kind of pleaded for it since. So when this wallet was hacked and they lost $30 million, they were pretty vocal in the community about doing another hard fork where they would recover the money. But after the first hard fork, which proved to be quite controversial, it's never happened since. The community doesn't agree, so it can't happen. Because as we talked about with proof of work, you need 51% of all nodes to agree, or else a fork's impossible. So that's the nuclear option, the most difficult but the most successful way of fixing an attack after it's happened. The other option is that people have been working on is there's certain ways that you can make a smart contract upgradable. So if I were just to deploy a normal smart contract through the network, I can't change it after that's happened. It's there forever. I can't change the code if I find a bug and so on. But some developers have worked out a way to get around that limitation somewhat, and you can upgrade parts or all of your smart contract. So then if you discover a bug, you can fix it in the contract rather than having to move everyone to a new contract. So these can fix the bugs before they're exploited, but they're also quite hard to write and hard to write in a secure way. But we will talk a bit about upgradable contracts and how to build them later on. I'll just pause to see if anyone's got any questions. Cool. So before we get into the interactive part of today, I just wanted to talk one more thing about the kind of Ethereum community, and that is how it's run. So because it's a decentralized network, there is no central person who's calling all the shots. There's no boss, or there's no government that runs Ethereum. It's a public protocol. It doesn't even have, say, a company behind it, right? It's just a group of people who've all decided together to work on this blockchain network. There is a non-profit organization called the Ethereum Foundation. What they really do is spend all of the Ethereum that they created at the start of the network on funding different developers to research and to develop new features for Ethereum, build applications on Ethereum and so on. So they have some say in what happens to the network, but of course the whole community has to agree. And because the network is decentralized, you end up having to make your decisions by the consensus of the community. So the whole community has to kind of work together to find the next steps for the network. And this is one of the really cool things about blockchain. So in Ethereum, we have this thing called an ERC, and this is, I think it stands for Ethereum Request for Comment. And the idea with this is that someone will have an idea about Ethereum, and they'll write up a big proposal, like they might say, oh, I want to be able to do this in a smart contract. I want this new instruction added. And then they'll submit that to the community and everyone can kind of debate it back and forth. And, they might suggest changes to it. They might point out problems with it. They might say, oh, I love this idea. I also want this. And gradually the community kind of decides on whether this proposal should be accepted or not. which is awesome. And if you look at, let's go to this website. So I go to, this is eips.ethereum.org, and you can have a look at this too, but this is the website for all Ethereum improvement proposals. So generally what happens is someone will submit an ERC, an Ethereum request for comment, that describes their idea. If enough people accept it, it becomes an Ethereum improvement proposals. Then there's more debate and so on, and finally it gets accepted or rejected. But if we look at, say, the core section, you can see here all of the different Ethereum improvement proposals that have been accepted by the community and built into Ethereum. So you've got things like someone wanted a certain instruction that could do data compression, right? So this group of people got together and they said, I want to be able to compress data in my smart contracts. They wrote up here kind of a description of it. They've said, they've got a summary, so it adds a certain hash function. It's got a motivation. So why do they want this? Why is this useful for the network? And why should the community adopt this proposal? Then they have the technical details, the specification, all the code and so on. They might add test cases and talk about, you know, how we can make sure that this is correct before we deploy it to the network, and so on. Then all of this is happening in GitHub, by the way. So hopefully you've all seen GitHub, which is like distributed version control. And all of these EIC or EIP, ERC kind of proposals are just open on GitHub. This is another one for a certain type of token. And then people can debate it just in the GitHub comments, right? So it's available for literally anyone. We could go on there now and make our thoughts heard on a certain proposal if we wanted to. But eventually, if enough people agree, then it becomes accepted into the network. So this is what happened for this 152 token. 152, sorry, function. And there's a bunch of these. You can also see a lot of these are written by, say, Vitalik Buterin. This is the guy who created Ethereum. And even he can't make a change without everyone agreeing. So he has to go through the exact same process as you and I would, which is cool as well, you know. In reality, whatever he says is usually a good idea, so everyone agrees with it. But if he did do something bad, people could disagree, in theory. Okay, so we'll talk more about alternative blockchains another time. There are a bunch out there that do smart contracts, but we'll go into that. Okay, so are there any questions there about that intro before we go into kind of how we can actually start using Ethereum? All right, so now, if I think everyone's at a computer, we'll do kind of a play along at home section. So I'll kind of show you how we can get set up to use Ethereum. All you need is a web browser. You'll probably need Chrome or Firefox. I'm not sure if it will work in Safari, so you might need to do that. Along this process, I'll kind of pause to make sure that everybody is up to the same spot. If you're having issues with your microphone, maybe just type into chat. Like if I ask, is everyone up to this spot, type in chat or put a thumbs up in your Zoom or something like that. But what we need is a way to connect to the Ethereum network. So as we saw, there are kind of 4,000 different nodes in the network. And these are the people who are running the network, who are adding transactions to it and so on. We go up to our decentralized diagram. These are the nodes, the ones here. But as we saw, it takes a lot of computational power to run these nodes. You need a lot of storage space and so on. So a lot of these nodes provide a service where people like us who just want to be able to send money back and forth can essentially borrow their node and send transactions through the node without having to run it ourselves. And that's this decentralized diagram here. You can see that each of these nodes that are kind of the central nodes are talking to each other to secure the network. but then they have all of these clients that are connected to an individual node that are using that node to access the network. You can think of these nodes as kind of gateways. So for us now who want to try connecting to the Ethereum network and doing some things on it, what we need is a gateway and a node to connect to. So what we're going to use is a browser extension. It's called Metamask. So if we go to this website, it's metamask.io. I'll put that in the chat. And this is a gateway. So MetaMask runs a bunch of nodes. I don't know how many, maybe 10 or so on the Ethereum network. And then they provide this kind of gateway for us to access their nodes and run transactions on them. So what you'll need to do is once you're on this MetaMask website, just go to the download section. You can choose whatever browser you're on and click the install button. And it's just like installing, an ad blocker or something like that. So I'm on Chrome or I'm on Edge. This might look slightly different if you're on Firefox, but it's pretty much the same thing. What you want to do is install this browser extension. And once it installs, you'll see it pop up here. Okay, so you'll see MetaMask, and this page should open as well. So once you've got it working, just type in the chat once you've got this installed, and then we'll go through together like how to set it up. Cool. Also, if you don't have a computer, just type that in the chat too, or you're not at a computer, so you're not following along, type that in the chat too, so I know who to wait for. I'll keep going on, and then if I go too fast, just yell out and we can stop and go through things again. But so you should have this little fox popped up, and it'll give you a happy message. We'll just click Get Started. You're new to MetaMask, and so what we're going to do is create our own Ethereum wallet. This is essentially creating those accounts we're talking about. This is going to be our identity in the Ethereum network. So you'll click this Create a Wallet button. Click No Thanks usually. This is asking if you want to opt into data collection. I always click No Thanks. Here you said,
can you send me the link to the homepage of this extension?
Yeah. If you've installed the extension, you can just click on the button and it will open up.
Oh, right. Got it. Thank you. Yeah.
All good. So this password this is not your secret key. We're still going to generate that. This isn't your private key. This is just to lock the browser extension. So if someone else were to get onto your computer, they wouldn't be able to access your account. So I'll just put like AB in. Correct that. Okay, so now in the background, what MetaMask has done is it's generated us a new Ethereum account. And I can click here to reveal, and I see those words just like we saw on the previous page, right? This here is my private key. This series of words. Now, this here, if anyone ever gets this gives them full access to your account, so they can do anything they want. So it's really important that if you're going to use it for real money, that you store it securely. For us, what we'll do right now is just copy it to a text document, something like that, because we'll need it in a second. So I'll put it in my notepad. I've just copied and pasted it. Then when you click next, because MetaMask wants to make sure you really know this phrase, because you need it if you ever want to restore your account or move to another computer or so on, it'll make you re-enter it by clicking the words in the right order. So I've got it open in Notepad and I can just click in. I know it's in this order, like crazy infant. Trying to fit everything on my screen. And mask, first, pair, grass. Weird winner. Crunch just traveled. There we go. When I confirm that, congratulations, you passed it. It gives you some tips on storing it safely. And when I click all done, I am finished. So I have created now an Ethereum account and I'm connected to Ethereum. So this is kind of the Metamask interface. It's a wallet of sorts, right? So this is just a credit card or a bank account. I can see that I currently have 0 Ethereum. I can see the address of my account. This is my public name. So if I look, so it's kind of hidden here, but if I type it into the address bar, you can see that's my full name. Yeah. So if I wanted someone to send me money, then I could give them that address. And here I can kind of buy Ethereum, send it to someone, and so on. Up in the top corner here, I can see the network that I'm connected to. And by default, you're connected to the Ethereum mainnet. This is the main global Ethereum network, where Ethereum is worth $3,000 and everyone is kind of connected to that global computer, which is awesome. But in kind of practical terms, when you're developing on Ethereum, you don't really want to spend $2 every time you test your program. So the developers of Ethereum came up with a solution to that, and that's what's called a test net. So if you click this little drop down here, we can see that we don't just have like an Ethereum main network, we also have all these different test networks. And this is where you can test your programs without spending real money on them. What we're going to do is we'll all switch to this Ropsten test network. I don't know why they're named like this, but they all have different features enabled. Ropsten test network is always the same as the Ethereum mainnet in terms of features. So if you click that, you'll see you're still using the same account, you're just connected to the test network. Okay. So now we still have 0 Ethereum, and to do anything on the network, we need to be able to pay our transaction fees. To do that, we need some Ethereum. Instead of purchasing it, because we're on the test network, we can get that for free. And that's what we're going to do next. So we're going to fund our wallets. To do that, what we need to do is we go to something called a faucet. It's like a tap. So I'll just send the link to this. Zoom chat. So this is a service provided by Metamask for people to get free Ethereum for testing. So what you'll do is open up this page, and now we need to connect it to our wallet. So I can click my little Metamask Fox icon. Let's get rid of this. I can see that that should be all there. And then if I click this button here, request 1 Ether from Faucet, I'm essentially asking Metamask to send me 1 test Ethereum. So I'll do that. If you click it, you'll get this little pop-up. Can you guys see a pop-up on my screen or not? Yeah. I'm just going to change my share so it's the whole screen. Okay, so I've clicked request 1 Ether from Faucet, and now I have this prompt. So Metamask is asking me, do I trust this application? Do I trust this site to use my account? I do, so I'm just going to click next, and then I'll click connect. Okay, so now I have requested 1 Ethereum from the faucet. If all goes well, so if you've done all of those steps correctly, you can see a new entry in this transactions list. What this is saying is that Metamask has received my request that I want 1 Ether, and they have created a new Ethereum transaction to send me that 1 Ether. If we click on this transaction, it's going to open it up in Etherscan. So this is exactly what we were looking at before. we can see that this is pending. So it hasn't been processed yet. It's been sent from the MetaMask account to my account, and the value is 1 Ether. So this is all the things we're looking at before. If you look up in the top left, you can also see that this is a testnet transaction, not a mainnet transaction, which is why the Ethereum here is worth $0. So let's see if that's worked yet. This might take a second, just while we wait for the test network to hurry up. There we go. So if you look in your wallet after a minute or so, and you look at the balance section, just like I do, you've now got 1 test Ethereum. So that's now like your money. You can send that to someone else and so on. If I refresh this page, I should see that transaction finished. Now, Alif, did your test Ethereum work? Have you got 1 ETH?
Yeah, it's still loading on my end.
Okay. What I might do, if you open yours, could you copy your address and then paste it into the Zoom chat?
Yeah, sure.
Cool. Excellent. Right. So now what I want to do is I'm going to send some of my Ethereum, some of my testnet to Alif. So I've opened my wallet, I'm still in my MetaMask. And if I lose this, it's just the browser extension. You click the little fox. Now I'm going to click on send. And here I can add any recipient. So because Alif has sent me his address here, this is his public name. I'm going to copy that in, paste it, and I'm going to add him to my address book. So I'll just click this and I'll say, I know this is Alif, and so on. Now I'm going to send him some Ethereum. So it's telling me I've got 1 Ethereum. I'm not going to send all my money to him. So maybe I'll send 1/10 of an Ethereum. So you can split an Ethereum down to something like 18 decimal places. So you can make a really tiny small amount. So I'm going to send him 0.1 Ethereum. Here is where I set my transaction price. Now I'll just leave it as the defaults for now, and we'll talk a bit about what that means in a second. When you're just sending money from one person to another, I know we're talking about the gas for a smart contract, and the more complex the program, the more gas it costs. A simple transfer between 2 people is always 21,000. So MetaMask knows that and it sets that for you, so you don't have to worry about it. I'm going to click next. It's going to tell me that to send this 0.1 Ether, I have to pay this amount of fee. So the total amount that I'll send is 0.100022. Click confirm, and that transaction has been sent. So if I will just wait a second. The Ropsten network seems to be a bit slow right now. Usually it's faster than this, but I'll get a pop-up in a second telling me that this was confirmed. Oh, there we go. If we see down here, transaction 0 confirmed, I'll click on that notification. Oh, it's long load. That's annoying. But essentially what's happened in the background is I've submitted that transaction. It says move 0.1 of ETH from my account to Alif's account. That was sent from this gateway to an Ethereum node. Then that Ethereum node sent that to all the other nodes in the network. All the nodes that wanted that transaction, that thought it was a good transaction, started trying to include it in a new block. And they were all generating blocks, all generating kind of hashes for a block. The first person to find a hash that gave the right number of zeros at the start, then submitted that block to the whole network. Everybody checked that their hash was correct. They checked that all the transactions inside that block were correct. And they agreed that that should be the new state of the database. And then eventually the whole block was accepted by the network and that transaction was confirmed. And considering that this then had just been accepted by, say, 1,000 people after all that, the fact that it runs in 30 seconds is pretty impressive. And in the actual Ethereum network, it's only something like 10 seconds, which is awesome. So I can see now I've only got 0.9 ETH, and Alif should see that he has 1.1 Alif ETH, which is cool. Now, what I'm going to do, you can also, if you click this little account options, click view on Etherscan. I think Etherscan might be having some issues because it should be able to see the two transactions that have been made to and from this account, but you can also see your balance. So now, because I know Alif's address, I can actually look up his balance anytime I want. So that's one of the kind of privacy issues on Ethereum, is that everything, unless you take steps to make it private, is public by default. So if I type Alif's address into my Etherscan and search for it, I can see he has 1.1 Ether. So it's pseudo-anonymous, which means, you know, it's not fully anonymous because I can identify who this address belongs to if I've seen it before, but without actually being told this is Alif, there's no way for me to link this address back to it. So it's kind of semi-anonymous in that way. Okay. Any questions on that bit?
Yeah, Kyle, I had a question. Is there any way to identify who is sending me the Ethereum, or the receiver cannot know?
It's a really good question. So by default, all you know is that address. Sometimes if you type it, if you put the address into Etherscan, someone will have set their name and you can see it there. See, there's this like my name tag section. But if someone hasn't done that, then there's no way for you to trace that back to them, right? That's the pseudo-anonymous part. So someone could just send you money randomly and you wouldn't know who it was.
Okay.
Which is why it's quite widely used for people making illegal purchases, like buying drugs online. You can use cryptocurrency and then it's not linked to your, you know, your real identity. However, there are ways of linking it to your real identity, which we can talk about.
Okay.
Okay, so just going to switch my screen again. Now, there are some kind of practical considerations to using Ethereum. One of them is that when I was sending that transfer, I used all the default settings. But as we talked about last week, the fee of a network, so the amount of extra Ethereum that you send with it, is what rewards the people who include your transaction in their block. So the node is rewarded for propagating my transaction through the whole network. So therefore, the higher the fee that I provide, the more likely it is that my transaction will be processed quickly. If you are trying to race against someone to get the best deal, say you've got an eBay smart contract and you're fighting someone in an auction, it's kind of in your interest for your transaction to be as fast as possible so you can beat them. In that case, what you might want to do is provide a kind of higher fee on your block, on your transaction, so that all the miners who see two transactions, they see that yours gives them a higher fee, they'll be rewarded better, so they'll pick yours instead. That's the kind of ETH gas station that I was talking about. And you can use this to send it in Zoom. What ETH gas station tells you is kind of what amount of fee or what fees you should pay in order to get your transaction processed quickly. So if I go to my transaction calculator, so TX calculator on the right, I can type in how much gas my transaction is going to use. So in the case of a transfer, as I said, that's always 21,000. But if I was running a smart contract, it might be 600,000. Then I can say kind of how fast I want my transaction to be. If I want it to run at the fastest speed possible, then I'm going to pay a higher amount per gas. So it's 21,000 times 22 GWh, which is a gas fee. or just on average, it might be 14. Whatever I put in here, if I click submit, I get a kind of breakdown of how fast my transaction will be. So if I send the average fee on the main Ethereum network, it might take 318 seconds to confirm on average, and it will cost me 80 cents. But if I want it to run as fast as possible, and I change my gas price to 22 and submit it again, now it's going to cost me $1.23, but it's going to run in 33 seconds. So 10 times as fast. And theoretically, I could send a custom amount and send even more gas than that. So I might say 100 rather than 22. And I can submit that and see that it'll cost me 5.56 or $5.6, so even more expensive. But at some point, it becomes physically impossible to go faster. So there's no point spending more. It's still going to take 33 seconds. One of the cool things in this output too is if you submit it with a lower gas price, say average, you can see this stat here, percent of last 200 blocks accepting this gas price. And because people can set different prices or different fee amounts, and then the nodes can pick and choose which transactions they take, if I set my price to be quite low, then over the average of the last 200 blocks, so maybe a day or so, only 60% of nodes would have accepted my transaction, put it into a block. So that's why it's a bit slower than if I put the fastest, which is quite interesting. Okay. So a little thing I wanted to show you, you might have to look at my Zoom camera for this, is we have been using what's called a software wallet. So our account is stored on our computer. That's what we're using to protect our funds and to make sure that our money is secure. But there's a few risks to that. So when you're dealing with real Ethereum, which you will be doing as a smart contract developer eventually, once you deploy your actual contract onto the network, that costs money. It costs real Ethereum to interact with the application and so on. So it's really important that you keep your account and your private key as secure as possible. So with a wallet like this, it's fine to just have on your local computer. But if you were to be hacked by someone, if your computer was hacked, there's a chance that they may find your private key and be able to steal your money. So one of the solutions to this is to use what's called a hardware wallet. So try and see, you can see this, it just looks like a USB stick.
Yeah.
And it's got a little screen, I can plug it in. But my Ethereum private key is on this device here. When I want to use it, so when I want to send money, the computer, once I've plugged this in, will send the transaction to this device. This device here signs the transaction, sends it back to the computer. So at no point does my private key ever leave this computer. So it never goes onto my internet connected computer or to anything that's publicly accessible. So as long as I've got this, it's impossible to steal my private key, which is really cool. So this one that I have here, which is the most popular, is called a Ledger Nano. They're pretty cheap. They're only like $100. So considering that might save you losing $10,000, it's a pretty good option. But I'll just share my screen too, so you can see this. It comes with a program called Ledger Live, and I'll open that up and show you what that looks like. So yeah, if you do start developing real applications, you have real Ethereum, I would 100% recommend getting these because it makes it way harder to lose your money. But you can see that you can connect to your device. So I'll just plug it in to my computer with a USB cable. Like this. Now, you probably won't be able to see this, but it asks for a PIN code. So I have a PIN code set on this. I'll just type that in now. This might take 1 sec, sorry. Bit annoying. Okay, there we go. There's only 2 buttons on it, so it's really annoying to type into, but we're connected now. I'll just approve this app. Right, now my computer is connected to this Ledger Nano S. And if I look in this app catalog, I can see that currently I have the Ethereum app installed on my Ledger, but it doesn't just work for Ethereum. You know, I can have a Bitcoin wallet on this device, or I can have Dogecoin or Ripple, or all of these other blockchains are all supported by the device. So you can store everything on it. And then you can use all of these securely. And you can do things just like in Metamask. So you can send money to someone, right? If I click send, I can put in Alif's address and send him real Ethereum if I had any loaded, and so on. And then when you actually make the transaction, it pops up on this device. You can approve it on here and it will sign it for you securely. So those are really cool hardware wallets. So the other thing that you'll need to do as you start to connect to the real Ethereum network is that you'll need to actually get real Ethereum, right? Which is worth money. To do that, you have to buy it using, you know, actual cash. So I don't know what the currency is in Bangladesh. What's your currency?
It's Taka.
Dhaka?
Taka, T-A-K-A.
Yeah, okay, right, Dhaka. So you'd have to pay real Dhaka or real US dollars. To do that, you use what's called an exchange. So this is just like a foreign currency exchange where you're trading Australian dollars for US dollars. There are a bunch of exchanges out there. Some of them are kind of more legitimate than others. The largest exchange in the world is called Coinbase. You might have heard of them. They just did an initial public offering in the US this year on the stock market and made an insane amount of money. But on this exchange, you're buying and selling crypto and converting it into real money or fiat money. So here I could buy a real Ethereum coin for 3,400 Australian dollars. And I can do that through this interface, you know, by funding it with my bank account and so on. So you would use an exchange like this to buy Ethereum. The other thing you can do is find someone who already has Ethereum and you can give them cash and they'll send it to you, right? So there's other options, but you need to somehow get actually Ethereum to be able to use the applications. Now let's talk a little bit more about what you can do once you have the Ethereum. So there's a bunch of use cases for Ethereum. There's obviously, it's a currency, it can run any program, but there's certain programs have been really successful in Ethereum, which we'll kind of talk about for probably the rest of today. And they're all generally around finance and currency, right? Because it's hard for a blockchain to interact with the real world, but we'll talk about how you can do that later on. A lot of smart contracts at the moment are around cryptocurrency and interacting with currency and making loans and things like that. So one that you've probably heard of is called, sorry, was some, sorry, I thought there was a question. One of the kind of big subsections of the smart contract ecosystem is what's called an altcoin. And just like Ethereum is a cryptocurrency that runs on the Ethereum blockchain, you can write any currency you want as a smart contract, right? So if I wanted to make a currency, I could write a program that describes that currency, and then I could run that on Ethereum and have essentially a cryptocurrency. So while there is a single currency called Ether, which is used to pay transaction fees, the Ethereum network can actually support an infinite amount of currencies. And that's probably one of the reasons why it's so widely used. There's this website here called CoinMarketCap. And what you can look at is kind of all the different cryptocurrencies out there in existence. Now, obviously, Bitcoin is worth the most by market cap. So market cap is the total value in US dollars of that cryptocurrency, followed by Ethereum. But then you start to see these coins like Tether or Binance Coin, what else? USDC, Uni Swap, Chainlink. all of these coins here are actually not a separate blockchain at all. These are running on Ethereum. Right, so the Tether cryptocurrency is just a smart contract, and it's been deployed to Ethereum. Everybody knows the rules. So they know the rules about how to transfer money, how to transfer from one person to another, who can transfer money, how new coins are created, and so on. So Ethereum has thousands and thousands of these altcoins, alternate coins, and some of them are worth an enormous amount. So Tether here is worth, what, $61 billion in total. And this is US dollars, so this is fiat currency. Each of these altcoins usually has a purpose of sorts. So one of the kind of major uses of altcoins is to make what's called a stable coin. So to explain that, what I might do is bring up an exchange for these altcoins. So we talked about Coinbase as one of the major exchanges. I'll bring up another exchange here called Kraken, just because it has quite a cool interface. So this is another exchange in the US. And this is the marketplace that I'm looking at right now. What I'm looking at here is the Ethereum to US dollar price over time. And this is from the 28th of May to June the 2nd. And if you haven't seen a kind of candlestick chart like this, it's not really important to understand, except to note that the level of this indicates how much Ethereum is worth at that time. So we can see that over like the last week or so, Ethereum has at one point been $2,800 and one point it was $2,100. So in kind of economic terms, this is an extremely volatile asset. The value of an Ethereum goes up and down insanely. Especially if we look at, say, the 5-year time. How do I switch to that? I don't know. Can't work out into it. But if you were to look at a graph of the value of Ethereum over the last 5 years, you'd see it go from worth 1 cent per Ethereum to now 3,000. So effectively, that means it's quite risky to hold an Ethereum because it might lose $1,000 worth of value in one day. And the reason for that is because it's a traded currency. People might be more keen on Ethereum one day and more anti-Ethereum the other day, and they buy and sell, and that changes the price. So to address this problem with Ethereum, that it's volatile, the price changes a lot, one of the kind of big advantages of smart contracts was that people could build what are called stable coins. And these are alternate currencies where instead of being freely traded like Ethereum or like Bitcoin, they are stable in their price. So usually they take a real currency like US dollars, and they make one coin on this altcoin worth $1. So if we look at coin market cap again, you can see that Tether is worth $1. And if we look then at the kind of price history of Tether, so if I look at the overview, you can see that, despite some blips, it usually stays pretty much bang on $1. So the highest it ever got to was 1.04. So the people behind Tether wrote a smart contract that took the idea of a cryptocurrency and kind of added new features to it. So because Ethereum is so flexible, because it's this global computer, they were able to build out that currency, which is really cool. Go back to the list. So other major stable coins, there's kind of 3 large ones in the Ethereum world: Tether, USD coin, and this is backed by Coinbase. So this is Coinbase, the largest exchange's official stable coin, and it's again worth $1. And there is another coin called DAI, D-A-I, and we'll talk a lot more about this because it's really interesting in how it works, and it's also worth $1. So you see there's kind of competing coins. They all might have different code that governs their smart contract, but they serve the same function. Then the kind of other type of altcoin or alternate coin on Ethereum is what's called a utility token. And these are things like Uni Swap, right? And these are a cryptocurrency that are used in a certain app only. So think about it, if Facebook wanted to make a currency that you could send and receive within Facebook, they might create a Facebook utility token, which is on Ethereum. It's a smart contract on Ethereum. People can buy and sell Facebook bucks. And that's what this kind of second group of altcoin is. So Uni Swap is an application on Ethereum, and its token that they've created is worth $27 at the moment. But you can see it changes a lot as well. It's not like a stable coin where it's $1 always. Over time, it's gone from like $4 up to $40. So that changes a lot. Now, on a marketplace like Kraken, usually what you're doing is you're swapping between a fiat currency, which is a real world currency, it's FIAT, it's called fiat, and that's like a US dollar or a DACA or Australian dollar, and then a cryptocurrency. So here we are looking at Ethereum swapping with US dollar. But what you can also do is start to swap cryptocurrencies with each other in an exchange. So I can look at something like, what's a good example? Here we go. So if I switch to this market here, I'm looking at the conversion between two currencies. One of them is Ethereum, so it's the cryptocurrency. The other is another cryptocurrency on a different blockchain called Litecoin. And I can trade these cryptocurrencies with other people back and forth. And this is generally how you would get altcoins. So I would have 100 Uniswap tokens, you would have 1 Ethereum, we agree to trade them. And there's a bunch of different exchanges to do this, like different marketplaces with different fees and so on. But generally, it's pretty easy to swap for the coin you want if you're willing to pay the price. So what I want to kind of talk about now is some of the problems with exchanges and how Ethereum can help, and use that as an example of what a smart contract actually does and what a decentralized application actually does. So if I'm using an exchange like Kraken or like Coinbase, this is a real company. So Kraken and Coinbase are in the US. I think Binance is in China, and it's governed by the laws of that country. So in the US, right, if you wanted to use Coinbase, you have to submit your legal identity. You have to upload a photo of your license to prove that you're not using Ethereum for money laundering, for example. Or if you are in China, you might have to upload your social security number, so on. So it's bound by the laws of the government. And these companies that run these exchanges also take fees. So it might be 0.01% of your transaction goes to the company. So it's a little bit expensive to swap money on these exchanges. So what people kind of realized once Ethereum pioneered this distributed computer that could run smart contracts is that they could code up an exchange that ran entirely on Ethereum and didn't have a company behind it. Right? So they could create a decentralized exchange using a smart contract that would let people swap their tokens with each other without needing anyone to run the exchange separately. It wouldn't be kind of beholden to government regulations. It would run worldwide and so on. And what would keep it secure instead of a company kind of looking after it is the fact that it's running on the blockchain. Everybody can see the rules of the smart contract. So they can see the rules of who can trade with who and how much it costs to trade and so on. And the consensus mechanism of the network, so the proof of work, then decides, is this transaction valid? Is this exchange valid? And so on. So we can replace these centralized exchanges with smart contracts. And this is another kind of big use case for smart contracts in Ethereum. There's a lot of decentralized exchanges. What I want to do now is kind of show off how you would use one. And this is our first example of a decentralized application and how it might look like for a user. So what I'm going to do is I'm going to go to an application called Uni Swap. And this just looks like a normal web app, right? So this could be, it's probably built in React, I'm not sure, but it's just like a normal web app that traditionally would be connecting to the bank server or the exchange's server, right? But what we're actually seeing here is a distributed application. So this application is running on Ethereum. It's going to connect via Ethereum and it's going to interact with a smart contract. So Uniswap is an exchange, right? You can swap Ethereum for another coin. And in this case, what I might do just for a demo is I'm going to swap some Ethereum, which I currently have in my wallet. If I look here, I've got 0.9 Ethereum. And I'm going to pick from any of these other tokens. So say I want DAI. DAI, this is a stable coin. It's worth $1 per DAI. So say I want $5 to buy, I don't know, a coffee, right? If I put in my $5, then the contract itself, so the smart contract, will automatically calculate how much Ethereum I need to pay. So we can see that to swap Ethereum for DAI, it costs me about $4.95 in Ethereum, and I get back $5 in DAI. So that's actually a pretty good trade. Now, to actually make this trade, what I need to do is call the smart contract or tell the smart contract that I want to run it. And to do that, I submit a transaction. So just like we submitted the transaction to transfer money, here I'm submitting a transaction to use the smart contract. Now, we've set up Metamask before. That's our wallet. That's our way to connect to the network. If I want to start using an app like Uniswap, all I have to do is tell it to connect to my current wallet. So I can click this connect to a wallet button. It provides a few options. I want to use Metamask. And then I get that pop-up just like before. It's asking for permission. So I'll accept it. And now we can see that my address here, so this is my account, is now connected to this app. We can see that we're on the test network. We can see that I currently have 0.9 Ethereum. And we can start to interact with my money. So it's reset here. I'll just quickly pick something else. Let's swap Ethereum for Uniswap. We're pricing back too high. So all of these warnings are being created by the smart contract. They're saying that if I make this swap, it might cause issues with the smart contract. Insufficient ETH balance. Let me just find what I can do. We might be having issues because we're using the test net and not the main Ethereum network. So what would happen usually is I would click this button to activate the smart contract. It would create a transaction which goes onto the network, just like our transaction between me and Alif. And the nodes would agree that I have called the smart contract correctly. It would run the smart contract and it would make that transfer all within the decentralized exchange. So there's no one in the world who could have stopped me making that transaction. It's really cool. So if I look at, this is kind of the current state of Uniswap. We can see that the total value inside the exchange now, and this is on the real network, is it's currently serving $1.82 billion worth of assets. So someone has written a smart contract, which no one can stop, no one can control. The whole network is securing it, and it's now holding $1.8 billion worth of currency. So I think that's a pretty cool achievement. And there's a lot of contracts out there that are all kind of holding as much or more money. And we can see, like, because this is an exchange, you know, you can buy and sell cryptocurrencies, and we've got all of these different prices and so on. And this is all governed by the smart contract. And one of the great things about Ethereum is that, whereas if I'm looking at Coinbase, all the actual code that's running on their server is hidden, because this is an application that's written as a smart contract and that's publicly available on the Ethereum network, if I don't trust this exchange, I can actually go and read the code myself. And I can say, yep, these rules look fair. I'm confident there's no bugs or there's no way to hack this system. I'm going to use this application and have confidence in it, which is awesome as well. And a lot of apps will just have like a link to it. So in the Uni Swap app, you can just click this link to their code. And this is their front end code. But if I go to their contracts, I have a lot of code. Here we go. Core smart contracts. It's all on GitHub, just like most code, right? And you can actually look at the smart contracts in the human readable language that's governing your exchange, right? So this is the exchange code. If you wanted to, if you were really, really paranoid, you can actually compile this code yourself and check that it matches the smart contract on the network. And then you can be absolutely certain that this is the code that's running. Okay. So I know we've only got 10 minutes left. So are there any questions firstly? Okay. So to kind of summarize today, we've gone through a little bit of an introduction to Ethereum. It's the most actively used blockchain, the second biggest blockchain by market cap. And what it does to kind of improve on Bitcoin is it takes the concept of a blockchain and it changes the state transition function to support smart contracts. A smart contract is a program that runs on the blockchain. So it's publicly spread across the whole world. Anyone can interact with it. And the consensus mechanism of the network decides whether the contract is executed correctly. So if I submit a transaction to the contract, the whole network makes sure that I'm following the rules, of the program, and then executes it. And smart contracts can transfer money, or they can serve as an exchange between different cryptocurrencies and so on. There's a bunch of information about Ethereum that you can kind of learn. I would recommend going on Etherscan. So that's this website, etherscan.io, and I'll put that in the chat. And having a play around, looking at some of the last blocks, some of the transactions and so on, and see if you can work out what's going on with each transaction. And yeah, have an explore of that. We talked a bit about the transaction fees, so how much you have to pay and how the network protects against people running programs that run forever. We talked about how accounts work, how storage works in the smart contracts, and then the governance process. So how the Ethereum community kind of decides on the changes to make and executes them. We've also started talking about the use cases of Ethereum and the use cases of smart contracts. So we connected to the Ethereum network using Metamask, and we're going to be using Metamask a lot more as we start to develop smart contracts. We looked at exchanges and how to, actually obtain Ethereum and other cryptocurrencies. And then we looked at our first decentralized application, Uni Swap, which is a decentralized exchange. So it takes an exchange of cryptocurrencies, of money, and it puts it into a smart contract, which is then run by the Ethereum blockchain. So it's quite a whirlwind. So if you've got any questions, just chuck them in Telegram like last week. And from next week, what we're going to do is start looking at more decentralized applications on Ethereum. So there's a whole world of what's called decentralized finance. And we'll have a look at some of the examples of that. We'll talk some more about other use cases of blockchain, of Ethereum, and so on. And then we'll start actually working on kind of hands-on development of smart contracts. So probably from next week or the week after, if you could make sure you've got a computer with you that you can access the internet with, that's all we'll need. But we'll start working on some smart contracts together. So
thank you, Cadel.
Yep. All right, let me work out how to stop the recording. Any questions? Oh, I can send the links in Telegram too. I'll send these slides as well.
Thank you, Gordon.
Cool. Okay, thanks everyone. I'll see you next week.
Thank you so much, Kedal. See you next week.
Bye.
Bye.